So what does the product look like? Well, in terms of the of a rack-mounted hardware, you can see the main radio module in a rack mount there, and I'll just show you a little more of the thing. Internally, that's just the receiver and transmitter half of it. The RF side of things consists of, as you can see there, the power amplifiers, the duplexes, receivers, and the whole thing is in a die-cast casting with some extensive EMI shielding to keep all the RF where it's supposed to be and to keep all the interference out. The same unit is fully sealed and can be designed to be mounted outdoors as well, where it's more appropriate, close to the antennas. One of the issues, of course, with MIMO is you have multiple antennas, and so therefore the antenna feed cables, you need twice as many of them, so if you can get it close to the antenna, there's a big incentive to do so. Speaking of antennas, one of the issues that we had in looking at the solution was that we needed a dual polarised antenna to get the full benefit out of the long-range MIMO effects, and most of the available antennas were a little bulky and a little complex to make them economic, and so we ended up deriving a number of antennas, but this is one of them, specifically designed to give us high gain, compact dual polarisation with good isolation between the two polarisations. Just the polar patterns of it, not terribly much to say about that. So what do we achieve? The system provides typical ranges of up to about 60 kilometres, greater than, we've tested over greater than that. Full duplex user data rate in a 25 kilohertz channel of 256 kilobits per second each way. So that's a substantially higher bits per second per hertz than most competing systems. Another key property of the system is overall latency. Because of some of the applications we're looking at, that's a key parameter, and we typically hold that down to less than 6 milliseconds. Power consumption is a big issue with anything with the degree of signal processing and such like in that. So, but the standby power consumption is down to 10 watts. The transmitter power consumption is a function of what transmit power you're choosing to run through that. The whole concept of the thing is that although it is quite a high technology solution, it's tended to be very simple to install and configure, not requiring any special setups or whatever. Largely looks after itself, and competitive cost, well, yes, hopefully. So just again looking at it in its various modes of operation, the system has a smart fallback system on the modulation to deal with channel signal quality. So it can be configured either at fixed rates or in adaptive mode. In the adaptive mode, it will progressively step back the constellation density to suit the channel interference, back through those with a corresponding reduction in data rates. The version shown there, the current product is in 25 kilohertz, just in the process of releasing a 12.5 kilohertz channel bandwidth version, simply half the data rates and half the bandwidth, and we are looking at wider band solutions at the moment as well. And you can see a table there with the different rates. Again, I'd point out that this is a full rate with no contention, and so it lends itself to compression techniques on top of that to give you a virtual rate which is higher, but the actual core rate is specified there. Just to put that spectral efficiency in context with a few other systems, this slide's a little bit old now, but we're achieving 12.8 hertz bits per second per hertz of totally utilised channel bandwidth. comparing it with a number of other standards, including the Edge standards, some of the mobile radio SAM standards, Tetra and P25, you can see that the spectral efficiency is substantially higher than any of those competing systems. And that's what our main sort of purpose is to squeeze more into less. One of the messages I guess out of all this is, with all the talk of broadband and other such things, don't forget about the narrowband channels. They have some significant benefits. Clearly, if you're looking to get long distance coverage, reasonable distance coverage, then some of the UHF bands and things offer a much better channel with better penetration through the environment, be it trees or whatever else, than the gigahertz type bands. And it is actually possible to get substantial data rates through narrowband channels. Obviously, in terms of spectral efficiency, that's important, but it's also significant in terms of the overall power spectral densities required in order to achieve a given data rate. So quite significant. So we achieve the very high spectral efficiencies, many times what's currently available in equipment. We do it within existing channels, so it often suits where there is existing channel allocations and things. And obviously one of the things we don't want to see happening in any of the channel planning is for these channels to disappear, or for people to say you can only use narrower and narrower channels. The moderate bandwidth solution still has got a lot to offer.